So we're going to jump right into graphing. Oh, that's a little blurry, so I'm going to rewrite it. We're going to graph y equals 3e, and the exponent is 0.25x. And so all of these today, they're going to have a base of e. We're dealing with that natural base. But they are very closely related to those exponential growth and exponential decay. So we're either going to have something that curves up or something that curves down. We're going to talk about when it's going to be growth and when it's going to be decay a little bit later on. But they're also going to have those asymptotes. The asymptote is still tied to a number that's added or subtracted back here. Well, this one doesn't have anything added or subtracted back here. So what do you think the asymptote is? 0. So I'm going to go ahead and I'm going to make this a little bigger, but I'm going to go ahead and I'm going to put an asymptote at 0. So that idea, that property still holds true. The number added or subtracted here is still where the asymptote is. So in this case, it's plus 0. We're still going to look to have 4 points to graph. I'm still liking that idea of trying -1, 0, 1, and 2. Got to be a little bit careful because we're using that e. We're not as familiar plugging into our calculator. So I am going to have us practice a little bit more. We do want to make sure we put parentheses around all that. So in your calculator, you're going to do 3 times. Then remember to get that e, you hit second and the LN button, which is like 2 buttons, 3 buttons down from the second. And it should pop up with also the exponent and a parenthesis. So then you should type in 0.25 times, and then you're plugging in -1, close your parenthesis. When you do that, you should get 2.34. If you don't get 2.34 or 2.33, then stop, try it again, or tell me. If you got that, go ahead and fill out the rest of the table. Go for 0, 1, and 2. If anyone's having trouble getting it, your calculator's different, or you're just having issues, let me know. And you can round to 1 or 2 decimal places. It doesn't matter to me. So you can see if you start matching with me, I have 3 and then 3.85. And again, if you just rounded to 1 decimal place, that's okay. And 4.95. So those all seem like pretty good things to graph to me. So I went ahead and started graphing those. So you can go ahead and start plotting those as well. Again, it's kind of far away from the asymptote, but we know that asymptote is at that 0 spot, so I am going to extend it down, getting closer to that as I get towards the edge of my graph. And I am, on all my graphs, I'm going to state the range. Dylan, what's the range for this one?
Y is greater than 0.
Yep, so you always find the asymptote. It's above the asymptote. Asymptote was at 0, so y is greater than 0. So don't forget to name your range. All right, we're going to try 2 more. Let's try y is equal to e exponent of 2x minus 3. y is equal to e exponent of 2x minus 3. So I'm going to make my table here in a second. Andrew, where do you think the asymptote's going to be?
-3.
Yeah. So again, it's the same thing we were doing a couple days ago. The asymptote's still in that same spot. So it's minus 3. So I know my asymptote's going to be at -3. It's just a little different plugging in with that e value. I'm still going to try -1, 0, 1, and 2. I'll just have you do the first one, the -1 value. When you plug in -1, you should be getting close to -2.9. And then I'll give you the rest of the values so we go a little bit quicker. We get 0 is -2, 1 is 4, 2 is 51. I say, yikes, I don't want to graph 51, I don't want to have to use a scale. So I got rid of that, and I said, well, I'm going to use -2. -2 was -2.98. I said, yeah, it's close to that, but that's okay. I know it's getting close to the asymptote. So I went ahead and I used those 3 points. So remember, you can always adjust the numbers in your table so you can avoid big numbers or really small numbers. So those are the 4 I'm going to plot. What types of graphs have these been so far? Growth or decay? Growth, because they're both going up. If I look at both of these, this one's increasing slowly, but it's increasing left to right. This one much steeper, it's increasing left to right. So both of these are growth. Oh, let's not forget, I do want the range on this one. Roman, what's the range for this one? Good. Asymptote was at -3. The curve was above the asymptote. So both of these are growth. So I wonder what a decay one we'll look at. Well, this is going to be a decay one. Y equals 2 e exponent -3x plus 1. What do you think is different about this equation that's made it decay? Yeah, something about the exponent. What about it, Carly? It's negative. And so that's what we're going to learn after we're done with this graphing part. When this exponent is negative, that's when it's decay. So when it's not an E1, it was whether this base was a fraction or not. Well, now the base is always E. And so that doesn't change. It's whether this exponent's positive or negative. I think we're understanding the table. So I'll just give you the table I had. Ooh, -1, 41. I didn't use that sucker. 0, 3, 1, 1.1, 2, 1.000 something, so it's just really close to that. And 3 was 1.000 something. I put the zeros in there because Kyle Rubio, where's my asymptote? 1. So I know these numbers aren't really happening at 1. I'm going to have to move them up just a touch. So my asymptote's at 1. And I'm going to plot these. Not that -1. So these last two I just put really close to the asymptote. And that curve is going down. Robert, what's the range?
Y is still greater than 1.
Yeah, it's still greater because it's still above the asymptote. So the range isn't dependent on whether it's growth or decay. The range is dependent on the asymptote, whether the curve is above or below the asymptote. So he's right. Y is greater than 1. Once you have this, you may want to switch to notebook paper because we're going to do some more theory type stuff about whether something's growth or decay. So natural base function is y equals a times e with an exponent of r times x. And they can be more involved. They can look like this. They can be y equals a times e exponent r x minus h in parentheses and then plus k. The only reason I show you this one is because of that plus k, and we know that k is going to be where we see the asymptote. What's going to be important on this slide is that r part, the part that's going to come before the x. That's what we're going to be focused on. That's going to tell us whether it's growth or decay. And really, we're going to see, I'll just uncover both of these. We're going to see that a is always greater than 0, so I'm not even going to have you write that part. For growth, the r has to be greater than 0. I think it's easier for you to remember, bless you, that it has to be positive. For decay, the r has to be less than 0. That means the r has to be negative. For growth, the r is positive. For decay, the r is negative. And this is going to be all well and good today. What's going to be tricky is when these start getting mixed up with what you were doing on, I don't know whether it was Thursday or Friday. I think it was Friday. And so when it was not the E ones, when it was the regular ones, you were deciding whether it was a fraction or whether it was bigger than 1. Well, now for these, you're deciding whether it's positive or negative. And when I mix those up, then that's when it can get a little tricky. You're going to write down these 4, and we're going to decide whether it's growth or decay. So go ahead and write down those 4. If you want to go ahead and as you write them down, write down G or D next to them for growth or decay. You can go ahead and do that. You're going to decide whether it's growth or decay. So we're looking to the R number. Emma, in number 1, what number is the R? The 4 is the R, and since it's positive, that's going to be growth. Number 2, Colby, what's the R?
0.02.
Good. So Colby, is it growth or decay? Good. Kyle French, what's the R in number 3? Good. Growth or decay? Good. And number 4, Savannah, growth or decay? Why? Good, because it's negative, so this is decay. All right, I'm going to throw one more up here. Let's say I have y is 2/3, and then the exponent is x. Growth or decay?
It's decaying.
It's decay. And this is what I was trying to say. Until we actually see it, we don't really understand. So these are all based on positive or negative because they're the E values. When I go back to the ones that aren't the E values, I have to decide whether this number is a fraction or whether it's bigger than 1. Since this is a fraction, this is actually decay. So tonight it's not going to be bad because tonight you're just deciding whether it's positive or negative. But when you go back and you start mixing them up, getting them ready for the quiz on Friday, we have to be careful. If you're looking at this kind, fraction, bigger than 1. This kind, positive or negative. So that's what we want to be careful about. All right, we are ready to start homework. You still got about 10 minutes. You're going to do page 496. You've got 31 through 34, 42, 45, 44, and 45. Not a very lengthy assignment tonight. Page 496, 31 through 34, 42, 44, 45. And I'll tell you what, if you finish 31 through 34, you can put your stuff up. 31 through 34 is just identifying growth and decay. I do want you to write down the equation though. So write down the equation, say growth or decay. If you want to put G or D, you are welcome to do that. You don't have to write out growth or decay. But you do need to write down the equation. So if you finish 31 through 34 and you want to take a break, put your stuff up, you can.